Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Algebra 1's Skills course. Today we're going to do some more work with completing the square. Now you guys remember from last time, we had y is equal to ax squared plus bx plus c. The first method that we would try to use on this was a method called factoring. And if we couldn't factor, then we would use x is equal to negative b over 2a to find the vertex. But sometimes we need to be able to solve these without being able to use factoring or using the graphing method, because the graphing method is notoriously inaccurate. And so we had a new method, one that always works, that was called complete the square. Now, if you remember, if I had something like y is equal to x squared plus 6x minus 3, I'm going to make that a minus 9. Here. We know, sorry about that, we know that this is not factorable. There are no factors of 9 that have a difference of 6. So what we'd have to do is something called complete the square. And this method is really easy. The first thing that we want to do is isolate the ax squared plus bx portion. So I'm going to turn that y into a 0, and we are going to isolate the ax squared plus bx portion. To do that, we add 9 to both sides. So we have 9 is equal to x squared plus 6x. After we have done that first step, we do the second and most difficult step, which is add 0. Now, the special 0 that we add is going to be in the format of b over 2 quantity squared. We're both going to be adding and subtracting that value. What this is going to do is it is going to create a perfect square binomial, or trinomial, so that we can turn it into x plus something or x minus something squared, which lets us resort to some of the other techniques that we already know. So I'm going to force this to turn into the thing that I want it to turn into. It's kind of like making a square peg turn into a round one. Mathematicians can do that. So here's how we do it. Our b value is 6, so I'm going to both add and subtract 6 over 2 squared. And when I do that, I get 9 is equal to x squared plus 6x. 6 over 2 is 3, 3 squared is 9. So plus 9, and then minus 9. From here, I'm going to add 9 to both sides, so I get 18 is equal to x squared plus 6x plus 9. After we add that special 0, we do our next major step, which is to factor and solve. So factoring this, I know it's going to be plus the square root of this number twice. So it turns into 18 is equal to x plus 3 times itself, x plus 3, which turns into 18 is equal to x plus 3 squared. I can then take the square root of both sides. Now when I do that, remember I have plus or minus the square root of whatever that number is, in this case 18. When I take the square root of x plus 3 quantity squared, I'm left with just x plus 3. Subtract 3 from both sides. I now have negative 3 plus or minus the square root of 18 is equal to x. Now I could try to further convert this, but that's really as far as we need to go in this class. if I wanted to find an estimate, I would have it say something like estimate to the nearest, or round to the nearest hundredth, or round to the nearest thousandth. Something like that. But if it doesn't say that, once you reach this point, feel free to box your answer and move on. So let's see it one more time, just to make sure that we have it down. Here we go. Let's say that we are given 0 is equal to 2x squared plus 12x minus 21. Make it 24, minus 24. Now on this one, actually 24 works out too nicely. Let's make it minus 18. Now on this one, the first thing that we have to do is isolate this portion of it, the x squared, the ax squared, and the bx. So then I'm going to add 18 to both sides. I have 18 is equal to 2x squared plus 12x. Now before I can add 0, I need to get rid of the number that's in front of the x squared. So to do that, I'm going to divide both sides by 2. When I do that, I get 9 is equal to x squared plus 6x. And from here, it's pretty much the same as before. We are going to add and subtract b over 2 squared. b is 6, so we're going to both add and subtract 9 to both sides. And it should look somewhat familiar, because now we have 18. Sorry, skipping ahead of myself. We have 9 is equal to x squared plus 6x, and then plus 9 minus 9. Adding 9 to both sides, we get the same spot we were at before. 18 is equal to x squared plus 6x plus 9. So we have 18 is equal to x plus 3 squared. We have the square root, so plus or minus the square root of 18 is equal to x plus 3. So we have x is equal to negative 3 plus or minus the square root of 18. Alright, now it's your turn. I will give you 10 problems, then I want you to complete the square. Then we'll go over them, and then we'll do 5 more and call it a day. So here we go. Number 1. 0 is equal to x squared minus 9x plus 8. Yeah, let's make it plus 7. Number 2. 14 is equal to 2x squared minus 6x. Number 3 is going to be 21 is equal to 3x squared minus, let's make it a plus. Plus 28. Nah, 28 is too nice. Let's go with 36, plus 36x. Number 4 is going to be 14 is equal to 7x squared minus 21x. And number 5 is going to be 0 is equal to x squared plus x minus 4. Alright, go ahead and solve for x. At this point, I would like for the sub to pause the video and allow them to work through all 5. Okay, let's go ahead and double check our answers. For number 1, we'll do that one first. I'm going to have negative 7 is equal to x squared minus 9x. From here I'm going to add and subtract 9 over 2 squared, so that'll be negative 7 is equal to x squared minus 9x plus 81 over 4 minus 81 over 4. So to turn 7 into something over 4 would be 28 over 4. So I have negative 28 over 4 plus 81 over 4 on the left, and over here I have x squared minus 9 over 2, sorry, x minus 9 over 2 squared. Doing some fancy arithmetic, let's see, 81 minus 28 is 8, 7, 6, 5, 53 over 4. Taking the square root of both sides, I have the square root of 53 over 4, of course we're doing plus or minus, is equal to x minus 9 halves. Add 9 halves to both sides, I have 9 halves plus or minus the square root of 53 over 4. Nothing works out quite nicely on this one, but it's not designed to. This is why the complete the square method is so powerful. Alright, so keep double checking for a few seconds, and then I'm going to erase. Alright, erasing. Moving on to the next one. The next one is nice and already isolated for me, so I don't have to do any arithmetic there. But what I do need to do is start out with the b over 2. So on this one, I need to get rid of that 2 first. So I divide both sides by 2 to begin with, and that gives me 7 is equal to x squared minus 3, which means that my b over 2 is going to be 3 halves squared, which is 9/4. So I have 7 is equal to x squared minus 3x, and then plus 9 over 4 minus 9 over 4. So again, I'm going to have to convert everything to over 4. So that's going to be 28 over 4 plus 9 over 4 is equal to x minus 3 halves squared. 28 plus 9 is 37. So I have 37 over 4, and I'm taking the square root of both sides, so that's going to be plus or minus the square root of 37 over 4 is equal to x minus 3 halves. Going to add 3 halves to both sides. And voila, we have solved for our x. Go ahead and double check your own work. Yeah, I forgot an x up here, sorry. Okay, going to erase and start on the next one. For number 3, it's already isolated, but I need to get rid of the 3 first, so I divide both sides by 3. When I do that, I get 7 is equal to x squared plus 12x. Now, from here I need to add and subtract b over 2 squared, which in this case would be 12 over 2, which is 6, and that's 6 squared. So I'm going to be adding 36 and subtracting 36 to this one. 36 plus 7 is 43. So I have 43 is equal to x squared plus 12x plus 36, which of course factors nicely into x plus 6 squared. Take the square root of both sides, so now I have plus or minus the square root of 43 is equal to x plus 6. Subtract 6 from both sides, I have negative 6 plus or minus the square root of 43 is equal to x. Go ahead and double check your work. Okay, going to erase. Okay, going for number 4. Again, I need to get rid of the 7 at the beginning, so I'm dividing both sides by 7, which gives me 2 is equal to x squared minus 3. Again, this one's going to be a fraction, so it's going to be 3 over 2 squared, which is 9/4. So I have 2 is equal to x squared minus 3x plus 9 over 4 minus 9 over 4. And when I do that, add 9/4 to both sides. 4 times 2 is 8. 8 plus 9 is 16. 17, sorry. 17 over 4 is equal to x minus 3/2 squared. Then take the square root of both sides, and I have the square root of 17 over 4, and of course that's going to be plus or minus, is equal to x minus 3/2. Have you ever noticed that this number is always the exact same thing as this number? Coincidence? Add 3/2 to both sides, and we have 3/2 plus or minus the square root of 17 over 4 is equal to x. Double check your work. Alright, time for the last one. Let's see if that squared thingy is still the b over 2 portion. I bet you it is. Could be mistaken, but I bet you it is. Let's find out. Let's do this one in red. Alright, first things first. There is a 1 in front of the x squared, so don't have to worry about that guy. But I do need to isolate the portion, so I'm going to add 4 to both sides to begin with. So I have 4 is equal to, x squared plus x. I'm going to be adding and subtracting b over 2 squared, which in this case is going to be 1 over 2 squared, which is 1/4. So let's see what happens with that. Now we have 4 is equal to x squared plus x plus 1 over 4 minus 1 over 4. I need 4 to be the denominator, so that's going to be 16 plus 1 is 17, so I have 17 over 4 on the left is equal to x squared plus x plus 1/4, which is actually going to be plus 1/2. Like this. Coincidence? I don't think so. It's actually by design. How about that, ladies and gentlemen? Alright. Square root of both sides. 17 over 4. Got the square root of that, plus or minus, is equal to x plus 1/2. So I end up with negative 1/2 plus or minus the square root of 17 over 4. Go ahead and double check your work. Alright. Now I'm going to move on to the next 5. And these 5, I know I said that I was going to do 10 before, but honestly, as long as it's taking you guys to do these, I think doing just 5 more and doing them for homework if you don't finish in class would be fine. So here's your class/homework. Number 1. Two. 3. 4. 5. and 5. Alright, go ahead and do those 5. Do them in class. If you cannot finish them in class, do them for homework. Good luck and have fun.